All right, we're back. We're still on page 4 of notes 9 of Calc AB, talking about derivatives of inverses. And let's see if we can keep rolling. So given that f of g of x equals g of f of x equals x, and the information in the table below. So this is a sneaky way of telling us that g of x equals f inverse, but also f of x equals g inverse. But I think it's probably going to be more relevant that g of x is f inverse. I mean, who knows, but usually that's the more relevant way, so whatever. Write the equation of the line tangent to g of x at x equals 5. All right, so g of x at x equals 5. So this is an x coordinate on g of x, right? And g of x is f inverse. Therefore, it's a y value on f of x. So that's a big deal, because now all I need to do is I need to find this value in the y values of f of x. This is the y value of f of x. So this is telling me that 3, 5 is on f of x. Therefore, 5, 3 is on g of x, right? Because they're inverses, so you switch it. So if that's the case, then g prime of 5 should be 1 over f prime of 3, because the slope of the inverse is the reciprocal of the slope of the original at the corresponding point. So we get this. So this is 1 over f prime of 3 is negative 3. So that'll be negative 1/3. And then we want the tangent line. So when you do the tangent line, so let me just highlight this. This came from here. So when you do the tangent line, don't mess it up. I mean, that's like stupid advice, but what I see a lot of people do is they use the wrong ordered pair, right? They'll try to use this ordered pair. No. We're doing g of x. So this is all the information we need for g of x. So our tangent line, so tangent to g of x at x equals 5 is going to be y minus 3 equals negative 1/3 x minus 5. There you go. All right, approximate f prime of 4 has nothing to do with inverses or anything, just pure review. So remember, when you're approximating f prime of 4, use y values, use slope of the secant line. You're not going to average derivatives, so we're not doing that. We're going to find the slope of the secant on this interval. So I'm going to say f prime of 4 is approximately, because it's almost certainly not equal to this. We don't really know that it's not, but it's almost certainly not. F of 5 minus f of 3 over 5 minus 3. So what is this? So negative 9 over 2. I'm going to leave that. So that's approximately it. You don't have to say mean value theorem. You don't say like, because it's continuous, it doesn't matter. You just use the slope of the secant line. All right, let's see if we can do this. Find the slope of f inverse, the inverse of f of x equals sine. Okay. Whew. Limited so it has an inverse. So how do you limit sine so it has an inverse? Negative pi over 2 to pi over 2. That's where you limit it, so it's 1 to 1, so it has an inverse, etc. At x equals negative 1/2. Okay, so this is the x value on the inverse. So we know that x equals negative 1/2 is on the inverse. So we need to figure out what makes sine of x equal negative 1/2 when x is between negative pi over 2 and pi over 2. This is all inverse trig stuff. If you don't remember your inverse trig stuff, bust out your math analysis stuff or head over to the playlist. There's a lot of stuff you can watch. There's one video that just is like all the inverse trig stuff you should memorize. That's probably a good one to take a look at. There's actually probably 2 of those. One because I like made a good video about it, and one because I went through all the notes. I put a lot less thought into like going through the notes because it's so much work to just go through them. But either way, you need to know this stuff. Review it every once in a while. It's not that hard to remember, I think. So here, the value is going to be negative pi over 6. If you remember inverse sine, we end up using just like this part of the unit circle. I thought that would become like I was waiting for it to become a semicircle, but it never did. So -1/2, it's sine, so it's like a y value, all like there. So that's -π/6. Okay, so -π/6, -1/2 is on sine of x. So -1/2, -π/6 is going to be on sine inverse. And what are we even doing? We're finding f inverse prime of -1/2. F inverse prime of -1/2. That's what we're doing. Okay, so I'm going to let g of x equals sine inverse. So g prime of -1/2 is going to be 1 over f prime of -π/6, which is, what's the derivative of sine? It's cosine of -π/6, and the cosine of -π/6 is the same as the cosine of π/6, which is radical 3 over 2. So this is going to give me 2 over radical 3. Okay, so we did that. Hopefully we got it right. Do this directly by finding the derivative of inverse sine and evaluating it. Well, I know the derivative of inverse sine. So d dx of sine, and you also know it if you did the implicit differentiation videos or notes. So we want to do this. Oh, actually, let's not put that in yet. We want to do that, but first let's just say this is 1 over the square root of 1 minus x squared. Okay, so then d dx of sine inverse such that x equals -1/2 is going to be, I'm having trouble fitting this, 1 over the square root of 1 minus square -1/2, you get 1/4, which is 1 over square root of 4/4 minus 1/4 is 3/4. 1 over square root of 3 over 2, 2 over the square root of 3. Same answer either way. That should not surprise you because this method works and we did it right. So we knew what we were going to get. It's easier to do part B for sure. Just remember the derivative. But the point is that it works. So if you forget it, you know, you could potentially get out of that trap. But I recommend remembering it. Remember everything. It's just so much easier. All right, I'm going to stop this video here. I'll be back in the next one to keep going. So see you there.